All right, welcome to day 7. We'll give you 2 minutes to check these multiple choice answers, then we'll go ahead and explain through each of them, but that way you know which one you should be paying close attention to. So we'll go ahead and we'll pause the video now for 2 minutes so that you can check those. All right, a lot of these multiple choice hopefully weren't too bad. So the first one, derivative, we just got a chain rule, so it goes 3x, then multiply derivative of the inside, so times 3. So we get choice E. Next one, when you do direct substitution, you get a 0 over 0, so we got to do L'Hopital's, do derivative of the top on its own, derivative of the bottom on its own. When you do direct substitution again, we just get 1/2. For 3, we've got an integral. We got to do u substitution, so let u equal 3x plus 1. We'll have a 1/3 d. Actually, hold on 1 second. This should say 3dx. So we'll have 1/3 du equals dx. We have a correction of a third there. After you do your antiderivative, don't forget your plus c. Fill back in the u. We end up with choice A. In 4, we want to find dy dx, so that's dy dt over dx dt, and we'll fill in the 13. So initially, you probably get this, but that doesn't match any of our choices. So a cos over a sine is a cotangent, but that's still not a choice. So a cotangent is the same as a 1 over a tan, and now that will match choice D. Euler's method, we got our 4 columns for x, y, dy dx, and our delta x times dy dx. We want a step size of 0.5, and we have to get to f of 2. So you should be able to first fill in these 3, knowing that we're going to go 1, 1.5, and 2, and they told us that y is 2. So fill in the 1 and the 2 into dy dx. We get dy dx is 3. Then do 3 times our step size of 0.5 to get the 1.5. That's what we apply to our y value to get the new y value here. Then sub those into dy dx. You get 5. Multiply by our step size. You get 2.5. Tack that on to get our next y value, which is 6. Basically, we've got this integral here, but think of it like if it was a series. Think of it kind of like a p series. So we would need 2p to be greater than 1 for it to be a p series that converges. So that means p has to be greater than 1/2. If we want the particle to be at rest, we do not want it moving in either the vertical or horizontal direction. So we want dy dt and dx dt to be 0 simultaneously. So take your derivatives of each of those with respect to t, set them equal to 0, and solve. For dy dt, there'll be no vertical movement at t equals 2 and -1, no horizontal movement at t equals 0 and 2. So at t equals 2, that's when there's no vertical or horizontal movement. So that's our answer. It's just a u substitution, u equals x cubed. Do your correction of a third, take your antiderivative and fill back in, so choice B. Our derivative rule for natural log is derivative of the inside over the inside. Or you can think of it as 1 over stuff times d stuff, and that's where we get the f prime. Then just fill in 0 for x, and we get back the -2/5. For 10, we want to rewrite this so it's in a nicer geometric form. So think of that 2 to the n plus 1 as being 2 to the n times 2. So then we can rewrite it as 2 times 2/3 to the n. Well, this is geometric, where we will have a sum because absolute value of r is less than 1. So when you sub in 1, we get back 4/3 for our a1, put on top. 1 minus r, we're multiplying by 2/3 each time. When you neaten that up, you get 4. In 11, so 1 over 1 minus x, that's where we're just starting with 1 and multiplying by x over and over again based on our infinite geometric sum formula, just like we did on the last one. So your initial is 1 plus x squared plus x cubed and so on. Well, if you have x squared over 1 minus x squared, really what that's saying is we want to sub x squared where all the x's are, and that would give us 1 over 1 minus x squared. And then we want to multiply everything by x squared, and that would give us the x squared over 1 minus x squared. So the second row there, I subbed in x squared for all the x's. And then the third row, I multiplied everything by x squared, and that's where we're getting choice D from. In 12, directly proportional means when you divide, you should get a constant. So based on the description, we said we had our rate of change, so dv dt, is directly proportional, so we should be dividing by something to get a constant. The thing they said we're dividing by is the square root of the volume, so square root of v. So that's what we would get based on the description, and then we've just got to find a choice that could match that. If you multiply the square root of v over, we end up getting choice E. In 13, not differentiable, we're looking for corner points, discontinuities, or vertical tangents. So we would have not differentiable at A, B, and D. And then of those three spots where it is continuous, it's just A. So 13 was A. For 14, x equals 0 gives us back a slope of 0. But notice all those differential equations would give us back a 0 when x is equal to 0. So notice in our first quadrant, the slopes are always positives. In the fourth quadrant, they're always positives. And in the second and third, the slopes are negatives. Well, these since x and y are positive in the first quadrant, that's not really going to help us. But let's maybe think of the fourth quadrant. X's are positive, but y is negative. So if we have a positive divided by a negative, the only way for that to turn in positive is if we're raising this to an even power. So we know the y's have to get raised to an even power in the denominator. That rules out choice A and choice C and choice D. Well, of the remaining ones, we have x squared and x cubed in the numerator. Well, here we're going to have a positive in the denominator for the y's. And here we'll have a negative, which we already know is raised to an even. So essentially that'll be positive in the denominator as well. So we need to make sure our numerator comes back negative. Well, for all of these, because we went left, we do get a negative. Because we want to keep it negative, we would want to make sure we're raised to an odd. So to be raised to an odd, we would want the x cubed one, so E. Moving over to the free response, there's two easy ones and two hard ones in question one. One wanted to know how many fish enter. So you just do an integral from 0 to 5 of the entering function, sub it in your calculator, round to the nearest fish. B, we want to know the average value that leave the lake. So average value is 1 over b minus a. So 1 over 5 minus 0. And then the integral of what you want to find the average of. So it's just our leaving function. And then we get 6.059 fish. So next we wanted to find when we have a maximum number of fish. They don't tell us at time t equals 0 how many fish there are. So to make it easy, let's just hypothetically say there's 0 fish. Because we're not finding what the maximum is, just what the maximum time is. So I created a function that represents the number of fish at any time. I called it f of t. So it's our integral from 0 to t, and it's the entering minus the leaving amount. Notice the second variable here in the integral has to be different than the t on top. We turn that into a dummy variable because we need the t when we go to take the derivative here in a second. We've got our interval. Your derivative, you're subbing in t and then multiplying by the derivative of t after, which is just times 1. Set this equal to 0 to find our critical values, which essentially is when e of t and l of t are equal. Graph, find the intersection, and we get 6.204. Well, from your graphs, you can see that the entering amount is bigger to the left, entering out is smaller to the right. So therefore we get plus minus. So you have your description and your labels for your relative max. And then to find the overall max, we got to check the endpoints and that relative. So f of 0, we had just hypothetically said it was starting at 0. F of 6.204. We'll now just go back up here, and in our f, just do the integral from 0 to 6.204. We get 135 and change, and then do it at 8 also. So we find out that the largest number of fish is going to be when t is equal to 6.204 hours since midnight. And the last one, we want to know when is the rate of change. So in other words, for us, that's what I called f prime. We want to know when is that, or if it's the rate of change increasing or decreasing at 5 a.m. So we would want to know if the f prime has a positive or negative slope. To know if f prime has a positive, negative, or slope, we got to look at f double prime. So here's your derivative of your entering to start out, minus. Now the derivative of your leaving, remember if you have a to the x, its derivative is a to the x times natural log of a. So we have 2 to the 0.1 t squared, that's our like a to the x. Natural log of 2, because that was the base, but because we didn't have just x in the exponent, we had to do a chain rule. The derivative of 0.1 t squared is just 0.2 t. And then from here, we're just summing in 5. Notice we get a negative value back. So since f double prime of 5 is negative, the rate of change of f prime of t is decreasing. You probably could have also, for that one, graphed f prime of t and sketched the graph of it and shown at t equals 5 that it had a negative slope. And you could say because f prime has a negative slope at t equals 5, then the rate of change is decreasing. That would have worked as well. And the last one, we wanted to find our area. Area is 1/2 radius squared over our interval. So you're just filling that all in the calculator. Just be careful to have everything in parentheses squared when you're doing that. Then the average distance from the origin, well, your radius is the distance from the origin. So if you want the average distance from the origin, it's just saying the average value of the radius. So average value is 1 over b minus a out front. So 1 over square root of pi minus 0. So that's where I have 1 over square root of pi. And then just integral of what you're finding the average of, which in this case was the radius. So that's where we got our setup from. We got 1.580. So those two hopefully weren't too bad. The next two might have been a little trickier. So they said we've got some line that's going to split this in half that goes through the origin. Imagine we got some line, that's probably not the half amount, but I just randomly drew it in. They said that the slope is m. So that's what I have drawn here. Here's a line with a slope of m. The reason we know it has a slope of m is because you're going up m and right 1. Well, let's find what this angle is here, theta. Tan inverse would just be m over 1, or m. So really we know that this spot here is going to occur when we have an angle of tan inverse of m. So there's two ways we can do this. The way that I showed here is I took our total area from part A and just multiplied it by 1/2. And I said I wanted that to equal the area from 0 to that tan inverse of m. And that would give us our value of m, because m would end up being the only variable there. That'd give us our value of m for that slope. The other way you could have done it is keep the right side the same, but then on the left you could have just done your area from tan inverse m to square root of pi, and that would have worked as well, and had those two equal to each other. Now the last one, so we've got k cos theta. So here's roughly a graph of k cos theta, what it looks like. And you can get that by just putting something in your calculator. And so what I graphed first is here's the blue one is 10 cos theta, and the red is our S section that they gave us. And so we want the k, the coefficient of that cos theta, to go to infinity. So what I'm going to do now is let's change that 10 out front to a 100. Well, notice now, and it goes way off the screen, we got our blue circle. That blue circle, as k gets huge, is essentially all of S's area that's in the first quadrant. So that means it's all of S's area from 0 to pi over 2. So to get this, we're just doing our area function, but it's only the first quadrant portion. So 0 to pi over 2, and that becomes 3.324. All right, so the rest of the period, you are working on your day 7 homework. Be sure to be helping each other out if you get stuck on things, and then we'll go over that on tomorrow's class. Have a great rest of your day.